Morning all. Welcome to another session of signals and systems. So last class we have seen what is the curriculum and we have seen what is a signal and what is a system. So in today's class we will study about some elementary signals. So the signals which we are talking about, the different types of signals. So things important is what are the elementary signals and what are the classification of signals. So in this session I will start with elementary signals. So let's see. So the first type is a step function. So I will directly go into the subject. So the first type is a unit step function. So what do you mean by unit step function? At least some of you might have already studied this. So a unit step function we'll study in two different ways. So first one, for a continuous time, how we define a unit step function, and similarly for discrete time, how we define unit function. Okay. So before that, before studying studying step function, you should understand what is a continuous time and discrete time. So normally we teach like classification. So we will say all the classification, continuous, discrete, even, odd, all these things we say, then we study elementary. So I will take all these things together so that we can save time. So before studying what are the two different, what are the classifications of elementary signals, let me tell you what is a continuous time. So continuous time means it will be defined for any time t. A signal x of t is said to be continuous. So continuous signal x of t, a signal it is represented by x of t is continuous. A signal x of t is continuous if it is defined for all time t. If it is defined for all time t, so schematically you can represent it like, so if you have the axis, this is time t, and if this is x of t, then a continuous signal x of t will be like this. So anyway, so if you can see here that it is so any point t you take, you know the value of x of t. So if it is, this is from minus infinity to infinity, so for any point on this axis you have a value for x of t. So that means x of t is continuous. Here t is the independent variable and x is the dependent variable. So that is about continuous signal. And if you are talking about a discrete signal, so then what do you mean by a discrete signal? So discrete signal means it will be defined only in some intervals. So only a discrete instance of time. Discrete signal means defined only at discrete instance of time, and it is represented by x of n. So graphically how we will represent it? Discrete signal x of n. So if we are talking about the same signal x of t and you want that to be represented in x of n, so how you will represent that? So the value of x of n will be present only in only a discrete form like this. So it will be like in discrete areas. So for every value of t, x of n is not defined here. We don't know the value of x of n here. We don't know the value here. So only at some particular points, so if you can define 0, minus 1, minus 2, minus 3, 1, 2, 3. So the value of x of n is defined only at these points for n is equal to 0, 1, 2, 3. So n is equal to 0 plus or minus 1. So only for these values only x of n is defined. So that is only discrete values. So that is about a continuous signal and discrete signal. So now you just understand we have two types of signals are classified into two types, discrete and continuous. So discrete is represented by x of t. So for every value of t you will get a value, and I mean continuous. Sorry, continuous is represented by x of t. So every value of t will get a value. And discrete means only a discrete instance of time. So particular intervals of time only you will have the value. So that is x of n. So representation is different. How that is how schematically. So only you understand this much. Now then we have other classifications, even and odd, energy and power signals, periodic and deterministic. So we will come to that later. Now you just try to understand what are the elementary signals. So in order to define the signals both in discrete and continuous form, I have just given you what is discrete and continuous. Now we will go into what is a unit step function. So unit step function, by the name itself, you know the magnitude will be equal to 1. That's why we say it is a unit step function. That is, area will be 1. Okay, area covered by the unit signal is 1. That's why always we say unit signal. So very basic concept, area covered by unit signal. So bit study is equal to 1. So going ahead, we will study different types of signals, and so unit step, unit ramp, unit impulse. So all these have area equal to 1. Okay, unit step function for a continuous signal. So unit step means we represent by u of t. So u is the representation for step. For continuous, you know it is t. So u of t is equal to 1 for t greater than or equal to 0, and it is equal to 0 for t less than 0. So here, you know, continuous signal, it is represented like this, no, x of t. So u of t is a particular kind of x of t, which is represented by using u of t, but it is defined only for t greater than or equal to 0, and the magnitude is equal to 1. So how you will represent that? Like this, t, this is u of t, and you know that u of t is defined only for t greater than or equal to 0. So how it will come? Like this. So t greater than or equal to 0, u of t is defined. Now coming to the discrete representation. So how you will represent? U of n, right? U of n. So here the bracket is like this. Okay, yeah, u of n is equal to 1 for n greater than or is equal to 0. So you know it is discrete values, not like all instant of time, 0.2, 0.3 and all, not there. So and 0 for n less than 0. And how you will represent that? Very easy. So we need to represent that only in discrete form. U of n, square bracket, u of n, and it will be like discrete values. 0, 1, 2, 3, 4, like that. Discrete one, and magnitude should be 1. That's why unit step function. Or if it is just a step function, means it can be amplitude will be equal to a can be any number, a equal to 1, 2, 3. So like that. So this can be a, and here since it's a unit step function, a equal to 1. So that is continuous time and discrete time. Okay. Now we will move on to unit ramp signal. Okay. So properties of unit step functions and all we will see in the coming classes. So just understand this is the unit step function. Now we will see what is a impulse function. So the next one is an impulse function. So let's understand what is an impulse function. Second one, unit impulse function. So unit impulse function is denoted by delta of t. So impulse means the representation is delta of t. Step means u of t, impulse means delta of t. And how you define that? Delta of t is equal to 1 for t equal to 0. So at t equal to 0, at the origin only, impulse function is defined. So t equal to 0 means it is 1, and everywhere else t not equal to 0. So at 1, 2, 3, minus 1, everywhere 0.1, 0.3, everywhere the value of the impulse function is equal to 0. And how you will represent that? The representation is like, so this is t and this is delta of t. So you know at only t equal to 0 it is defined. So let me use another color. So this is how you will represent it. at t equal to 1. So this is an unit impulse, so we'll give the value as 1. Okay, so this is in the continuous domain, and when it comes to the discrete form, so everywhere we study both continuous and discrete. So that is a systematic way we'll understand. So remember, it should be a square bracket. So delta of n for 1, it is equal to 1 for n equal to 0, and it is equal to 0 for n not equal to 0. And what are the properties? Now we will see some interesting properties of impulse function. The first one is, so I'm just not just explaining the basics. We'll study important points also, so that we need not study it later. It's very easy to understand it here itself. Integral minus infinity to infinity delta of t dt is equal to 1. Because why it is equal to 1? Because delta of t is defined only at t equal to 0. So it will be integral minus infinity to infinity delta of t dt is equal to delta of t at t equal to 0 only. So that is equal to 1, same. So that's why that is the first formula. And then second one, very important, listen carefully. Delta of n minus k. So that is, we are shifting it, is equal to 1 at n equal to k, and it is equal to 0 at n not equal to k. So you may not be familiar with what you mean by shifting. So this is something called shifting of signals. So a signal which was initially at n equal to 0, we are shifting it to another value equal to k, or it can be k equal to 2, 3. So let's see how you do that. So delta of n minus k, and this is about shifting. So how you do the shifting? I will tell you. So n minus k equal to 0. So n is equal to k. So that means at n is equal to k, the value of delta of n minus k is equal to 1, and everywhere else it is equal to 0. For example, how? If k is equal to 2, then our impulse function will be defined that this is 2. Then the impulse function will have the magnitude, if it's a unit impulse function, it will have the magnitude equal to 1 at delta at n is equal to 2, and everywhere else it will be equal to 0. That is all about shifting. Now let me tell you a very important relationship, very important and interesting relationship. So this is how you build your confidence in signals and systems. So we have studied step function and impulse function, and now I will give you a relationship between two. Delta of n is equal, and also you studied what is shifting. So impulse function, delta function, and the shifting property together will give you a formula. Delta of n is equal to u of n minus u of n minus 1. So let me show you that. Let me show you that graphically. So u of n. So u of n, you know that it is a step function. So it is defined only for n greater than 0, right? So this is 0 and this is u of n. So how u of n will come? Like this. U of n, u of n, u of n. Like this. So it will be. So let me take it up to 0, 1, 2, 3, 4, 5. Up to 5. We will take n equal to 5. And now we need what is u of n minus 1. So n minus 1 means how it will come? So you know that u of n is equal to 1 at n equal to 1. That is n equal to 1, not n greater than or equal to 1. And it is equal to 0 for n less than 1. So how you will represent that? 0, 1, 2, 3, 4, 5. So u of n minus 1, how you will represent? So it will be defined from 1, 1, 2, 3, 4, 5, 6. One more point will come. So this is u of n minus 1. We have shifted it to 1. Here it was initially starting at u of 0. So red, this also should be red color, right? Because it had a value at u of n is equal to 0 itself. U of n minus 1. So u of n will be equal to 1 for n greater than or equal to 0, and for 0 for n less than 0. So u of n minus 1 means it will be 1 here. So now what they are asking, u of n minus u of n minus 1. So you might understood this much will get cancelled. So what will be the answer? U of delta of n will be, so you get the elementary delta of n signal, right? Delta of n, and this is delta of n. So what property we have used here? What all properties we used here? Revise the understanding of what is a continuous signal and what is a discrete signal. So that understanding we had here. Then what is a step function? What is a step function in continuous time domain and discrete time domain? And similarly, we talked about a unit impulse function, but that too in a continuous and discrete domain. Then we studied about the shifting property. So some point which is defined at n equal to 1, how it will behave at n is equal to 2. So we are shifting it n minus a. Okay. And then we understood the relationship between, so how to subtract a signal and obtain another signal. So such things also we understood. So that is about the impulse function. So now we will study some more important properties of impulse function. F of t. So f of t, let f of t be any function. F of t into delta of t will be equal to f of 0. Why? Because delta of t is defined only at t equal to 0. Graphically, let me show you that. So this is t and this is f of t, and let this be a signal here, and that is being multiplied with delta of t. So you know what is delta of t. Delta of t is a signal like this. I'm not taking different color every time. It's time consuming. Same color I will use. You understand this. So this is 1. So f of t into delta of t will be what? The same signal here. The same delta of t signal, because at other points we cannot define. So only this signal will come in the multiplication. Right? The rest will be 0. Anything into 0 is 0. And the fifth property, f of t into delta of t minus t naught, if it is shifted, like if it is at some point here, how it will happen? It will be f of t naught. Logically, you might have understood that. Sixth property is delta of k into t is equal to 1 by mod k. So don't think about the derivation here. Just understand the formula. Delta of kt is equal to 1 by mod k into delta of t. For example, if you are taking delta of 2t, that will be equal to 1 by 2 into delta of t. Okay. And then another point, delta of t is equal to delta of minus t. So on both sides, the positive and negative axis, it will be same because it is defined already at t equal to 0. So that is equal to 1. That's it. So now we will talk about ramp signal and we will wind up. So just 3 signals we will study today. Before that, one thing I want to correct here is this will be mod of 2. Okay. So this is mod 2 only. Okay. Yeah. So coming to what is a ramp signal. So by the time it will be, you might have understood what is a ramp signal. So it is denoted by R of t or R of n. So continuous and discrete domains you have R of n. So R of t is equal to t for t greater than 0, and it is equal to 0 for t less than 0. So greater than or equal to 0 it should be. And how you will represent that. So it is a very familiar one. You might have studied all these things in your lower classes also. Very easy one. 1, 2, 3. So for any value of t, so t equal to 1 means for t equal to 1, 1, t equal to 2, 2. So the curve will follow both the axes. So it will be like this, t equal to 1, 2, 3, 4. So this is how it will go. R of t and this is t. So this way it will go. And then For R of n also you can define the same way. n greater than or equal to 0 and 0 for n less than 0. 0, 1, 2, 3, 4. So how it will be? It will have discrete values, increasing discrete values. Okay. So let me give you some important relationships. So relationships connecting step ramp and parabolic signals. So very important examination point of view. So integral of u of t will be equal to r of t, and also u of t will be equal to d by dt of r of t. So that's why in the first class I told you should be very familiar with calculus, differentiation, integration and all. And when it comes to impulse, integral delta of t is equal to u of t. So delta of t will be equal to d by dt of u of t. So then how we will connect? Integral, double integral delta of t is equal to r of t. Similarly, delta of t is equal to d square by dt square of r of t. So these things you can connect, because now how you know how u of t is defined, how r of t is defined, and how delta of t is defined. And you know that integral of 1 is equal to t, and d by dt of t is equal to 1. So use that concept, use that logic, and then you will understand that these results which I have written here in red color is correct. That's your job. So by doing this, you will understand the concept very well. So I hope whatever we have studied today is clear for you. So we are studying about the elementary signal. So we studied what is discrete and continuous signal, and then we defined step function, basically as unit step function in continuous time and discrete time. And also we studied a unit impulse function in continuous and discrete time. And then we studied about a ramp signal, that two in continuous and discrete domain, and how to interrelate between them, and then important properties also of the three signals. So I hope it's clear for everybody. Thank you.